Hello. I'm Dror HELPER. This is the session about the secret unit testing tools no one ever told you about, right? Just a disclaimer before we start. When I say tool, I use the term very loosely. I'm talking about ways to improve your unit tests. Okay? So if I'm not showing this latest and greatest create your own test using AI thing, you'll have to forgive me. A few words about myself. I'm a consultant and software architect. I work with a bunch of other consultants in a company called Practical Software, where we create solutions for clients, projects essentially. And I've been developing software for more than a decade, quite a lot. Somewhere along the line, around 2008, I started working for a unit testing tools company called AutoMocking, where I learned about unit testing, TDD, and Agile, fell in love in the topic. And since then, I've been going around teaching unit testing, mentoring developers, speaking at conferences, because I really care about it. And you'll notice. I also have a few courses on Pluralsight, unit testing in C++. Any C++ developers here? Okay, good for you. This is a .NET conference, right? Everybody here knows .NET. The examples will be in C#, don't worry. And I have a blog at helpercode.com, and my Twitter handle is thehelper. Feel free to reach me and ask questions, comments, say what you think. Always happy to answer. So, why do we need to talk about unit testing tools? Essentially, if you want to learn unit testing, all you have to do is go into Google and Google unit testing, and you find a tutorial about NewUnit, probably, or some other unit testing framework that will show you how easily and quickly you can write unit test and test your code, and that's that, right? As simple as that. That tutorial will probably show you something simpler. We like to use calculators in our trivial example. This is a more complex example I usually use in my workshops. And it's a unit test, right? Anyone who ever wrote a unit test have seen something like this. Who here never wrote a unit test? Ever, right? All of us know this is a unit test, correct? Because of this. So now it's a unit test. And what does that unit test do? Well, I'll create a fake repository in the first line using fake it easy, which I like, and create two products and tell my fake repository to return those products. And then I'll get to the next part where I actually do something and check the result, and I should pay 300 imaginary money for whatever product I've just added. And it is a unit test, right? Well, in this case, maybe. But it's not necessarily a unit test just because I'm writing it using NewUnit, in this case, a unit testing framework. The problem with the unit testing framework, which usually look like this, I've been teaching this in Java and .NET and C++ and many other languages, and all of them, a unit test will look the same. I have a method, and that method adds something written on top of it, mark it as a unit test, and then there's the name of the method, which is bound by how we name our methods. I can't use spaces or weird characters, but I can sort of write my test name. And then comes the actual test, where essentially I can write whatever I want. I can put here everything up to and including the kitchen sink. And I've seen people write whatever they want inside the unit test, not necessarily a unit test. You can write whatever code you want. You can start your whole server, if you like, inside this method, because essentially a unit testing framework is a method running framework. It has nothing to do with the unit test. Just a way to run a method in a very nice way and get a result back, but it's just that. Doesn't do much other than that. And that is a problem. That is a problem because I do care about what I write here. This is the important stuff. This is how I test that my code actually works. This is how I benefit from the fact that if I'll accidentally introduce a bug, it will tell me that I have a bug in my system, the reason we actually write this unit test. And the unit testing framework does not help me in any way or form. In fact, in some places, actually does the exact opposite. Not intentionally, but makes me write not so good tests. And I usually come to this point and say, everybody knows what a unit test is, right? A very clear definition of what a unit test is. It's a test that tests a unit of code, right? And what is a unit of code? It's something being tested by a unit test. Because we never got a good definition there. There's no good definition for unit tests. We can talk about a unit test property should be fast and isolated and reproducible and so on. And that's nice. But I won't try to define a unit test. I did in the past, but I'm not doing that anymore. You can find many different definitions for unit test. I want to define what a good unit test is. Because as a developer, I need to be a pragmatic developer. I need to use those things to help me, not just to write a unit test for the benefit of writing a unit test. So a good unit test should be easy to write, easy and fast, right? No one likes to write tests. And it takes time. And it takes time that I should be using to implement new features and fix bugs. So I want it to be easy and simple to write a unit test as quickly as I can. I want to be able to read it later on, because a unit test, when you write your unit test and it passes, that's nice. But the real benefit of a unit test is when it fails. Essentially, the only reason I write a unit test is in order to see it fail sometime in the future. Could be tomorrow, could be in a week, could be in half a year time from now. And when it fails, I want immediately to know why. And more likely, I want to know how to fix the reason it failed. So the unit test should be readable. That should be the #1 priority when writing a unit test. Someone else should be able to understand what it does. Someone else can be me in 2 months when I forgot exactly what I did. And finally, a unit test should be trivial to maintain. I do not want to start each and every morning by fixing 100 tests that failed because someone changed something in the code. I want the unit test to fail for 2 reasons, and 2 reasons only. I want it to fail when a new bug is introduced to the system, and I want it to fail when a feature request somehow changes my existing knowledge on how the product works. And those are the only 2 reasons I want the test to fail. Unfortunately, it doesn't always work this way. We've all been there when you get someone changes something and 100 tests fails, and now you spend time understanding what immediately changed and how the tests were affected. In fact, this is the #1 reason people stop doing unit tests, because if you spend too much time writing unit tests and then fixing them without a clear understanding why they failed, then you stop doing unit tests very fast. In fact, in one company where I worked, the developers spent a month writing code with good unit tests. And they had this team leader which didn't really care for those kind of things. And one night when he was hacking away, all of the team's tests stopped compiling. You know what he did? Well, he didn't ignore because they stopped compiling, but he deleted them all. The whole team came the next morning, no unit tests whatsoever, because they hindered his ability to write code. Plus, there's a cultural thing going there as well, but that's harder to fix. So I do want all those free, and I want my tools to help me achieve those objectives. And unfortunately, there's no clear guideline or tool that will help me write good unit tests. That's up to me. There is one guideline. Most of you probably heard about the AAA. Who here ever heard about AAA, arrange, act, assert, right? So you can say, okay, it's all fine, but we have AAA, and AAA says that a unit test should be built in a specific order, in a specific structure, and that structure should contain those 3 parts. And when I do that, without thinking about it too much, usually I'll create good unit tests, or at least readable one. And the idea is that the first part is arrange, where I set up all the objects, new things up, and set up my fake objects and mocks and whatever. And then there's a play button called act, where I start my system after setting it up. And finally, as the name suggests, an assert that checks the result of the unit test. Following those 3 steps will create better tests for you, and you should. But that's not enough. That's not enough because no one tells us what to put in the act, what to put in the arrange, what to put in the assert. And then we start doing very strange things, which in the end will cause a lot of problems. Let's go one by one. We'll start with the arrange. The reason I'm starting with the arrange, not because it's the first, but because that's the most painful part in a unit test to write. If we look at the example unit test, like here, the arrange part is more than half of the test. And it should be. I should have a very simple place where I start my test, the act. And I shouldn't have too many asserts. In the end, we'll get to that. So the arrange is the big part. And not only is it the big part, usually duplicated across the tests. I usually write it more than once. And you know what, that's fine. One of the hardest things to accept as a developer is that when writing unit tests, it's okay to duplicate code. I know some people which find it painful to see duplication in the code, and there are ways to improve it, but it's okay because I want the test to be readable. And fixing 100 tests, adding a parameter, or changing something in how I arrange the system will take less time than trying to understand very complex model or structure or architecture that someone just put in order to reduce the amount of duplication. That's a balance we usually look for. And so I have this arrange. Here, this is an old code of mine, very old. It's a Windows Phone application. Remember those? And that Windows Phone application, well, I was very obsessed with Stack Overflow at the time. And I wanted to be notified when my reputation went up or down. And back then, we didn't have any clear API. Today, we have very nice API with Stack Overflow. So I wrote this small application which will scrape Stack Overflow HTML, look for the reputation. That's not in this specific piece of code. And if the reputation went up, it will write in green the new reputation. If it went down, it will write it in red. And if nothing changes, it will remain white. This is what we see here. In the beginning, I'll create a user. This is my user. It has an image URL, reputation, and then I'll create another user, essentially the same user, but after X time has passed. And then I'll fake the user repository using mocks. Or in this case, Windows Phone, we didn't have a good mocking framework at the time, so I wrote my own class that mimicked my connection to Stack Overflow. Just a class that you call a method, return whatever I told it, and I told it here to return the first user, then the second user. And then I'll invoke asynchronously. This is how we used to do that at the time. And get the view model back. And then I'll call load user. I had the timer going around and calling that method every few seconds in the beginning. Then I was blocked because I didn't like it, so I turned it into every minute. And in the end, I'll check the result. This is the last two lines. And in this case, because the reputation hasn't changed in this test, I'll check that the result is white. Not the best design, but it holds. So what is the problem? The next test will look almost identical. The only change will be the second user, right? I'll want to check what happens when the reputation goes up or down or something strange happens. And so on. I've ended up with writing the same test, copy-pasting this test all over the place, just chasing a single digit. It has two problems. First of all, it was very frustrating for me. And second of all, it's very hard to tell by looking at the test what is the difference between those tests. So I was looking for good ideas, and everyone who ever read a unit testing tutorial know about this. This is the test initialize because it was written using a Microsoft unit testing framework in NewUnit called setup, and there are different XUnit uses constructors. And this is essentially a part of the test that will run before each and every test. This is the first method, test initialize, automatically triggered before every test, and then my test methods become very clear, very small. And by the way, if you look online and read very good books about unit testing, this is exactly what they tell you to do. I don't agree, but that's my experience and my belief. And why I don't agree? For two main reasons. First of which, essentially what I did here is split my test logic into two parts. When that test fails, I need to go all the way up, look at the initialization. Usually it is the first method, second method's in the test class. And then go down, scroll all the way down, and try to debug those two parts together and try to understand what went wrong. And that's very frustrating and very hard to do. The second reason is that once you start using test initialized, you have to add this guy. You have to have fields in your test. Well, the tests, we call it a test fixture or test class, essentially is a class. So you can add fields. It will compile, but I'm not sure whether or not that's a good idea, because those fields start to become a shared state between your tests. And one test can essentially affect a second test. Well, it depends on your unit testing framework of choice. If you use NUnit, they use the same instance. If you use Microsoft or XUnit, they don't. Actually, one of the reasons XUnit was created is due to disagreement about this specific feature. Because once I have a field that will remain the same instance between the tests, one test can change the state in a way I haven't thought about, and it will affect the second test. And then your test will fail in the build system, but then you'll try to run it on your computer, just that test, and it will pass. And that's very frustrating, because now you have an understanding that you don't know what happened. And when you don't know what happened, well, you try. You run all the tests, and your test might fail or pass, because this order in which the test run depends on your test runner, and you might use in 2 different test runners. Some of them even change the order in between runs. But let's say you manage to run it in the right order. Now you get to play binary search with your test. You run all your tests, and the tests fail. Now you run only half of them, and the tests pass, so you run the other half. And then slowly, in the course of a few hours, you finally find the offending test that caused the problem. And it's not fun. Very hard to debug, and a waste of time. I don't like doing that. So that's why I don't like using setup and initialize in unit tests. There's a good reason they're there. They're there for a different kind of test called integration tests, where I need to set up a database or create a file or delete a folder or call a server. And I don't care about those things in my test. I just want them to be there. Then I'll use those methods, but not to write actual test logic. Another funny thing that happens is that the next developer in line, that could be me in a week, will write a slightly different test and need a slightly different setup. And then he will go into the setup that already existed there and add a few more lines and change my test, either for the worse or not affect them anyway. Usually it's for the worse. Then I have 2 outcomes. Either my test fail, which is good because he'll understand he did a mistake, or the test will pass and test something completely different and no one knows about it. So I don't like those. What can you do with them? Oh yeah, this is a good one. We'll get there. This is a method written by a good friend of mine, very talented developer. Very important to say it. I'm not shaming people. This is what setup methods become after 2 tests. In fact, in this case, when opening this file, you know how many tests there were there to create this horrible, horrible setup? 1 test. He was looking at his test. He said, oh, I don't like all this initialization. This initialization does absolutely nothing for me. All I need is this service, the last line. And I need all those fake objects just to make it work. So I write a huge setup with everything so it won't pollute my test. But those things tend to become very unclear. In fact, with some clients, when going into their code, finding those setups, while you start to clean up and move the logic back into the tests, you find out that you don't need half of those objects in most of the tests. But you need to carry them on because someone just wrote it in the beginning, and you don't want that. So what can you do? First of all, refactoring. We'll take the logic that is duplicated, extract it into a method. In this case, I'll create a user with a specific reputation. All I care in my test are the user's reputation. So I have a create user method. Sorry about the naming. This is the hardest thing to do, to good names, hard to find. And that's it, right? So, and now it's very clear what the test does. The reputation is 10, remains 10, this is the result. That's cool. Also known as a factory method. And unfortunately, factory methods in unit tests start to become very convoluted as time passes, because in the beginning I had a very clear way to create my user. Give me the reputation, I'll set up the rest of the data automatically with something valid that you don't really care about in your test. And then someone come along and say, yes, that's correct, but I don't need to change the image from time to time. I want to check what happens when the image changes. So I write another factory method. And slowly but surely, I'll add more and more factory method for each and every permutation of initializing that specific object. And if you have a lot of objects, huge domain model, a lot of things to set up, you'll end up with a few dozen factory methods. And it's very hard to maintain them. And we don't like maintenance in unit tests, it takes time. So we need something better to do. And there's a pattern for that. That pattern was created way back in the original design pattern book. The pattern is known as the builder pattern. Who here ever heard about the builder pattern? Okay, so most of you. Who here used builder pattern in unit tests? Excellent, good for you. When I started doing this session, no one knew what I'm talking about, and now I got a quarter of the room. That's excellent. So essentially, let's move quickly. A builder pattern says that I have an object that will create my objects. And it's very similar to the factory method in a way, because I have this object and it has a bunch of fields. I'll set them up with default values, good values, but I don't care about them. And when I call the build method, I will get back an object, and that is essentially a factory method at this point with the class. But then I'll add a few methods to update, to adjust to my tests. For example, if I want to change the username in that specific instance, I'll call the method with name. And as you can see, I'll return the user builder. That's in order to create this nice Fluent API. And then I can write something like this. Dear unit test, please create a new user with repetition 10. And that's it. Now, the good thing about using the builder pattern, which was intended exactly for those purposes, when you have a lot of fields or data to set up, but you only care about very little subset of it, and then you set up all the fields automatically, well, sort of automatically, you have to write some code for it. By the way, ReSharper has a nice refactoring to turn a constructor into a builder that you can use. And yes, you set up your method with the default values, and then you only tell it what you care about. In this test, I only care about reputation, and I get two benefits out of using the builder pattern. I don't need to initialize this huge data object, this huge data model, and I've been doing that with a lot of builders. You can build hierarchy. The user has a connection and an email and whatever, and he lives in this address. And the person who will read this test will understand exactly what I care about, because he only sees the field I'm changing, and that's it. And that's what's nice about using the builder pattern, especially for building your data, your inputs for your unit tests. Now, another thing that will help me create objects easily is AutoMocking containers. Let's make a quick check. Last time it was 2. How many people will use AutoMocking containers? 1, 2, 3, 4, 5, 6. Nice. Okay, the rest of you will start using them from now on. What essentially an AutoMocking container does is you take an IOC container, IOC, inversion of control container, you know them, Ninject, AutoFac, whatever, Castle. And instead of returning a real object, it will still return a real object I need for my test. But all of the dependencies I haven't told it about will be returned as fake objects. And if you go into NuGet, you'll find a bunch. You just write AutoMocking and your favorite IOC framework of choice, and you can probably find someone already written a way to use your IOC container with mocking. And with your mocking framework of choice, if you use mock or fake it easy or whatever, you can just find AutoFac with fake it easy or Ninject with mock. They're around there. You can also write it yourself. It's not a lot of line of code. Essentially what it says is, when you look for a class, if I haven't told you anything about that class, please return a fake object. You can do that in 10 lines or less, using the examples in the internet. But how does it work? Well, might look like magic. And here we are. This is the test from before. In the back, just raise your hand if you can't see it. You can't. So, better? Still can't. Okay, I'm running out of screen space. Okay, excellent. So as I said, there's a bunch of fields here. They are painful for me. And there's a setup method here and a bunch of initialization. Essentially, the initialization got absolutely nothing to do. Just return a bunch of default values and then in the end, I'll get my service back. And this is essentially a test. This is what I care in the test. This is a good test, essentially. All I need to know about the test is here, but I need to maintain the initialize method, which I don't like, and get a result back, a text result, and check the assertion, and that's sort of nice. But let's just comment that out so it won't interrupt us. This is the same test using AutoMocking. So what do we have here? I'll use AutoFake. AutoFake, it's fake it easy on top of AutoFac. But and by the way, you don't need to use the same inversion of control container you use in your test, in your code. Just use whatever makes sense to you. And in AutoFake, I'll tell it to resolve one type and another type, and just set up the things I care about. Essentially, those 3 lines replace all of the code we see in the setup method automatically. And then I'll tell it to resolve my service, the one I want to test. Create the real object with a bunch of fake dependencies. And in order to believe me, usually what I do, I'll just put a breakpoint over here inside the class constructor, because I use constructor injection in this case, and running the test. Yes, you don't want to. So I'll use resharper instead. And hope for the best. Here we go. And move aside, please. Go away. So we got here. And as you can see, and if you can't, I'll just increase it. All of the dependencies were automatically created as fake objects. The ones I told it about will have my instances in. The one I didn't, just a fake object. And that way, when this constructor will change with things I don't care about in my test, the test will continue to run and pass unless I'll introduce a bug. I don't need to maintain this thing. Changing the constructor, changing the test, changing the constructor, changing more tests. I don't care for that. And I automatically got all of those fake objects just in order for the test to pass, because I don't really care about the logger. There's no point to create a logger by hand. Just use an AutoFake, and you're done. And there are a bunch of things, a bunch of framework like that. And you can read a very good example from Mark Simon blog explaining about AutoMocking. But essentially, that's it. There's no magic other than just setting up the container correctly. Okay, going forward, asserts, the last part. Anyone who ever written a unit test might find a problem in the next code. What is the problem in this test? Yes, 2 asserts, right. Because we know about, there's another rule, there's a range act assert, that's the AAA we talked about, and there's the 2 assert per test rule, or more likely 1 assert per test rule. This is a rule we'll talk about. We say don't use many asserts in your test, because if you do, you'll end up with something like this, right? I've seen those. People, well, as developers, we try to conserve space, time, and whatever. And so we write everything in a single test with a bunch of asserts in the middle, violating both AAA and 2 asserts rule. In fact, this is 5 tests bundled inside one method, and it has many problems. For example, if the second one will fail, I have no clue what happens with the rest of them. And I want to know as much information as I can when my test fails in order to understand and fix the problem. So I don't like to do that. I don't like to use more than 1 assert per test. Really? First of all, something you need to know about the 1 assert per test rule. It doesn't exist. I've searched in the internet. No one ever told you should only write 1 assert per test. I couldn't find, it's not attributed to anyone. No one talks about it, not written anywhere, but we do know about the 1 assert per test rule. And there's a good reason, because most of the bad unit tests use more than 1 asserts. So 2 asserts are probably bad. That's going not completely logical, but almost. If you have more than 1 assert, then a junior unit tester will say, okay, if you have a good junior unit tester will say, if you have 2 asserts, then it means you have 2 tests. We need to split it into 2 different tests, because we want to know everything, and writing a lot of asserts will mess up my test. But it's not really true. It's not really true because of things like this. This is the test from the beginning. I'm essentially testing one thing here, not two. I'm testing the result. The result has an idea and the content, but I am testing one thing. I am using two asserts in order to test one thing because I have to. There are ways around it, we'll get to that. And the problem with this, essentially, is that while it's conceptually the right thing to do, it doesn't make my test a bad test. I do have one problem. And the one problem is that when an assertion fails, it will throw an exception. That's the way assertions works in C#, in .NET, essentially. Doesn't matter which unit testing framework you'll choose. And I've seen them all. All of them will throw an assertion exception when an assertion fails, in order to tell your unit test runner that you have a problem. It seems like a trivial and elegant way to do that, but there's a problem, because if I have more than one assert, it means that I only know about the first failure. And if I have a class, a result, with 5 fields, I only know about the first one, which is not correct. And there's a difference between getting the message with the wrong ID and getting a completely different message with everything wrong. And I want to know that difference. I want all this information. And in C++, by the way, all you C++ developers, almost every unit testing framework does not throw exceptions. For good reason. First of all, in C++, for an exception, usually end up with a segmentation fault. So you don't want to do it. And second of all, exactly because of that. Most of the C++ unit testing framework will get an error, an assertion. By the way, you can choose whether or not to stop the test or not, but they're not throwing an exception there. And write that down somewhere. And when the test ends, it will check out if there were any errors and give you all of those errors back. And the only reason we're doing that for exception in C# is because of JUnit. You can blame Java, that's fine. JUnit was the first unit testing framework, the first freely available general unit testing framework, and it uses exception. And since then, every single unit testing framework that looks and acts like JUnit, NUnit, Microsoft MS Test, XUnit, does the exact same thing. And it was very frustrating, because I do need to check several fields on the same object, and there are tricks around it. You can override equal and get hash code in order to check your whole object and not just one field on top of it, for example. But it's painful, and I'm not allowed to do that in production code in every single class most of the time. And I got fed up with this, and a while back, and you can see from the URL, we're talking 9 years ago, I wrote this, not so bright, but method, that essentially will run a bunch of lines, doesn't really care what's there, catch all the exceptions, and then output them in the end together. And then I can write something that looks like this. I have a bunch of asserts, and if they fail, I'll collect all the exceptions back, and then throw them together. And you get all the information. The ID is wrong, and your actual content is wrong as well. And that's cool. And well, there's good news, by the way. NUnit has it as well. The new NUnit, newer NUnit, also known as NUnit number 3, has assert multiple, which does something similar to this. But if you're not using NUnit, like Microsoft Unit Testing Framework, you can write your own. Just a matter of running a bunch of actions, catching the exceptions, and throwing them together in the end. And that's it. And now I get to check for a bunch of things in a single test. Now, a word of advice. Just because you can doesn't mean you should. Sometimes it's not a good idea. The only question is whether or not I'm checking the same thing. If I'm not checking the same thing, if I'm checking a bunch of objects, doing that will mess your test. But now you can. What is the difference between those two lines using any unit testing framework that you can think of? Assert 5 is 2 plus 2, well, both of them are wrong, but, or 2 plus 2 equal 5. Any idea? Exactly. One of them is called expectation, the other one is called usually actual, or something similar. And when you get the error back, One of them will give you the right error. I expected to get 5, but got 4, and the other one will say that the other way around. Doesn't seem like a big problem unless you're actually testing more complex code, which usually you are. And then the test will give you a result that, you know, when you try to fix things after lunch, the middle of the night, I don't know, when is your low point in the day, and you start getting the wrong answer back, the wrong error message, then you need to debug, and the error message will confuse you and make you think that something completely different happened, and you read the code and something looks bad. There's also this. Notice assert equal and assert is true. Assert is true is something that I always talk about because people tend to use it all the time for a good reason. If unit test framework while doing the business correctly, all we needed to do is true, because it's more logical to write in code what I want to assert than use the right assertion. There are many assertions. I need to choose the right one. I don't want to. I just want to make sure that this is true. Unfortunately, when it fails, it only says, okay, it's not, it's false. With no data whatsoever, I need to open my debugger. It will take me a few minutes. I don't like doing that. I want to see all the errors together, especially if it failed on my build server where I can't really open my debugger. So what can you do? Well, you need more tools for that, because it's confusing choosing the right assert. Issue is equal, parameters, and there are asserts people don't know about. And then you need a string assert that will help you check that a subset of your string is correct. There's a collection assert people don't use to check that all the values in the collection or what collection equals to another collection. If you ever wrote a for each statement inside your unit test, you should check collection assert. And we all care about the error message. When my test failed, that's the important stuff. I want the right error message. And I got fed up as well a while ago, and I wrote something I called assert helper, because I like to stick my name on stuff. And assert helper has only one method. Assert that, or I expect that, because I didn't want to step on any unit testing framework API. And you give it a Lambda function, and it will analyze the Lambda function and run the right assertion, either in NewUnit or MS test. Haven't been maintained forever. I'm always planning to go back and fix that. And in fact, I haven't invented this one. Microsoft did. Microsoft had a framework that you had only one assert. And unfortunately, that framework was Silverlight. And when Silverlight went away, the unit testing framework went away as well, and no one ever did that ever again. And they should. There's no reason not to write it. It's not trivial, but simple code to write. And you can use it. If you want to, submit a pull request, I'll be happy. And you only need to write whatever you're testing in code, because we developers like to write and read code. And there's Fluent assertions, which you might have heard about. Fluent assertion is, yes, excellent. Or shouldly. And Fluent assertions are both help you write good assertion. Here I have two objects. I want to compare them, but I don't want to compare the ID. And you get very good error messages out of those libraries. And you can write more complex assertion that you need, because usually I compare objects and not just the ID. And you can do that. Just go into NuGet, look for Fluent assertion, add it to your unit test, and you're done. And that way your assertion, and more importantly your error message, will benefit, and you will appreciate it when your test will fail in the worst possible moment. Let's talk about test organization. Test organization is what I call the problem, because we don't know what to test, we don't know how to name our tests. And there are talks about how to name your tests, because essentially it's a method name, and somehow you need to both have a clear method name, and on top of that, something that people will understand how it works, and there are different ways to call your tests. Hint, test 1 is not a good name. And on top of that, what should I test? I have this huge code base, and now I need to test it using unit test. What parts? What is that unit? And how do I do that? And the unit test framework won't help you. TDD might a little, but there's something else called BDD, behavior-driven development, that was invented as a way to fix the problem in TDD, in a way, in which I'll outline a specification, I'll tell what I want to test, and then write code behind that will run those steps. And I use those especially for acceptance and integration tests, because it's easier for me to say, when my server is up and I get this request, this is the result. Writing the code is complex, very unreadable, but I can put it in nice boxes in order for everyone to understand. Now, BDD was invented in order for product managers and testers to understand what we developers are doing and have a clear conversation, which unfortunately tend not to happen in most organizations. I tried to make my product owner write those specifications. He didn't want to. And so I ended up writing them myself and then sending them over to the product owner and says, okay, is this what you want me to do? This is your requirement written in a more clear, concise way. He says, yes, no, or don't bother me right now. And BDD in .NET, we have a bunch of those frameworks like Specflow, very nice framework, in which I'll write the specification in they call the Gherkin syntax. Given I have this, when that happened, then this is arrange act assert, right? Given when then, arrange act assert, very similar. It forces me to have a clear structure because otherwise it doesn't come out as clear English. It gives me exactly the parts of my test, which is very hard to see when looking at a bunch of unit tests, the code. And when the test fail or passes, with my code behind, I can tell why. Unfortunately, it means I need to write the same thing twice. Once for my specification, once for the code that actually runs the specification, and I can't be bothered, it takes too long. And if my product owner is not willing to write the specification, I'm not really achieving anything here. And luckily for us in .NET, we have something called BDDFI. BDDFI enables us to write the specification in code. When you think about it, it's really clever. It will look in your method names, and it will look for the Gherkin syntax, given when then. And then when I run it inside my plain old unit testing framework, I will get back a nice result written with all the steps that I can run to my product owner and says, is this what you want? One client needed to submit his product for this official body to make sure that they tested everything. We just gave them this and said, okay, this is what we're testing. Is this good enough for you? And it forces you to have a good test name. It forces you to have good parts of your test, which are essentially reusable. Debugging tend to be harder, but when using it, usually you know where to put your breakpoint because everything is very simple, very concise, very clear. And when it fails, you know exactly why. And it will create an HTML file along the way that you can put in your build system and everybody will see it. And manager will like this stuff with the red and green circles and everybody's happy. That's fine. Now, suppose you've been successful with unit test. In this point, you probably have a few 100,000 tests. And each and every time you change something, you need to run a lot of things. And it's a pain. And well, there are a bunch of tools, and there are more and more tools added there every day, which will run your test automatically in the background, depending on your machine. This machine has 2 cores. It takes a while, but if you have a good, strong development machine, probably won't notice it. And those tools called the continuous testing tools. This is, well, they're not. There's no good name, but that's what I use. And the idea is that when I change something in my code or in my test, only the test or the code that is affected will run. And you get it with .cover. If you have ReSharper.cover, you have it. If you use Visual Studio Enterprise Edition from 2019 or 17, you have it in. It's called Live Unit Testing there. There's also a very good tool called nCrunch. It's the most powerful one in this field. And the company is to work in and no longer affiliated with TypeMook as a TypeMook runner. And those, essentially what those tools does is run coverage on your code. Then when you change something, it knows exactly which test to run for you. And so, well, we'll try to run a demo, but there was a slight hiccup in the beginning. Here we go. Here I have a bunch of tests for my assert helper library. And if I'll create a bug, replace the true with false, and save and build, you can see that immediately it knows that something's bad here. And as I said, 2 cores will take a while, 4 cores you probably won't notice. Only runs the tests that are affected by that single line for me in the background. If you have 2 screens, all developers should have at least 2. Some has 3, some have more. Then it runs on one screen or on the side, and you can see the colors changing as you write your code. Very nice to do TDD with those kind of tools. And you can see here with the coverage exactly what I affected. And if I'll change it back and save and build, in this case is waiting for my build, then only that test will run. And it will save you a lot of time, because if I have 2,000 tests that run for even 2 minutes, 2 minutes is a lot of time for me. But usually they run for 5 or 10. 6 times running all my tests in 1 hour is not enough. I can write my code and get the test immediately. And that's exactly the way I want it to be. So, those were the tools I use daily in order to improve the way I write tests. And I learn about what I do from them, with them along the way. And as I said, when you create your system, you want to check and use the builder pattern, especially to create your data for your tests. When you have a lot of data, that's one way to do that. There are other patterns, for example, we used to use a certain prototype, get a bunch of, especially when you call another server, web APIs, some web API, you get a lot of things back, save that JSON, load it into a class, change all the fields you want, wrap it inside the builder, and that's it. And there's the AutoMocking container. In assert, multiple asserts, now you know how to do that. And third-party assertion library, Shouldly, Dror HELPER, well, I'll fix it. And Fluent assertion, BDD, and finally, continuous runner. If you use .NET Core, there's something called Corvlet, which you want to check. That will do that for you in the background. Thank you very much. If you have any questions, we don't have a lot of time. I'll be here around, but if you have a quick question now, I will be happy to answer. No? Okay. Well, enjoy your lunch. Thank you.